Let's check it out. You deposit $378 in the savings account at the local bank. Anytime you put money in the bank, what's happening with that money? Interest. So it's growing. So this is a growth problem. So number one is a growth problem. All right, so where does 378 go in our formula? You guys want to guess? A stands for your beginning amount, where you're starting. So we're starting with $378. 378 goes right there. Everybody good? So A is your beginning amount. All right, let's keep reading. The account pays 2.5% interest compounded yearly. You guys want to guess where the interest goes? Interest is interest rate, so it goes for R. So now watch, I got to show you something. 2.5%. You guys are supposed to know this. You cannot put a number in a formula if it's got a percent sign. What do you have to do first? Move the decimal point back twice. So we're going to put in 0.025. Put it in that spot right there. 1 plus 0.025. Let's keep reading it. Find the balance after 11 years. We only got one more variable, so 11 is your X. All right, anybody have a question how I set that up? So now you just type it straight into your calculator. So these are not going to be bad. Y'all do this last year. Growth and decay. 378 times 11th power. All right, I got $495. Now look, guys, since this is money, do y'all see where it's 0.9687, blah, blah, blah? We got to round that off to money, so we need dollars and cents. So is that going to be 96 or 97 cents? 97. 495 and 97 cents. So I do want you to round it off anytime it's money. I got you. All right, let's do number 2. All right, let's read the problem. You guys tell me if it's growth or decay. The snipe population in Waynesville is the highest in the country, but the population is decreasing. So it's going to be decay. All right, so we got a decay problem. All right, which movie, for extra credit, which movie had snipes in it? Do y'all remember? You guys never saw the movie Up? Really? You missed Up?
I seen Up.
Okay, remember that's what they were searching for, was the snipes. The bird? Yeah, the bird. Remember he called it a snipe. All right, so anyway.
You ever been snipe hunting?
Nope.
You don't want to.
Is there really a snipe?
No, my family calls it snipe hunting, but they'll take you and put a bag over your head and leave you in the woods.
Yeah, I think there really is a snipe, but it's just like a small bird. It's not like, it's not like what was on the movie.
Don't go snipe hunting.
All right, anyway, let's get back. So how many snipes are we starting with? What's it say in the problem? If there are 75 snipes currently in Waynesville, so we put 75 for our beginning amount. What goes in for R? Now look, it says 7.3%. So what do I put in the formula?
0.07.
Good. 0.073, because it was 7.3, move the decimal point back twice, and it says for 8 years. And then you just type it straight into your calculator. All right, type it in. Let's see what we get. So we started with 75. 1 minus 0.073 to the 8th. All right, so how many snipes are we going to have? My calculator says 40.8. Is it possible to have 40.8 snipes?
No, you have to round down.
So we're just going to round down and say 40. Good. 40 snipes on that. All right, now all of these are not this easy. Some of them are a little bit different. Let's keep going. Let's go to 3. All right, 3 is a different problem. Let's look at it. Y equals 125. All right, so number 3, they are giving us a formula they want us to look at. And by looking at this formula, you guys have to figure out, is that a growth problem or a decay problem? All right, watch. Y'all see where growth starts at 1 and decay starts at 1. Y'all see that? So think of it as $1. How much money is that right there? 85 cents. So has it gotten bigger or gotten smaller? It's gotten smaller. It started at $1, right? In the formula, Harley, it starts at $1 there and it starts at $1 there. So it's gone down to 85 cents, so it is clearly a decay problem because it has gotten smaller. Now, how much smaller did it get? No, it started at $1, right? How much did it go down by? 15 cents. So look, if it went down by 15 cents, you move the decimal point back out, it really went down by 15%. So that's how you do those problems. You look inside the parentheses, see how much money's in there. I like to think of it as money, it makes it easier for me. And then you can figure out if it got bigger or got smaller. All right, next one. We're going to save number 4 for last because I think that's the hardest one. Let's go to 5. All right, number 5. The number of unicorns have doubled each year. So is this growth or decay? It's got to be growth. All right, what are we starting with? 1,024 unicorns. All right, so here's a trick. It said double. What does that mean? If you double something, you're multiplying it by what?
2.
2. So in here we put a big old 2. I don't put 2 plus R or 2 plus anything. If it says doubled, put a 2. What if it says triple?
Put a 3.
What's quadrupled? 4. Okay. So now we got to figure out how many years. Can y'all figure that out by what it gives you? What's it say? 2012 to 2018. So that's 6 years. So that's how you do one like that that says double. 1,024 times 2 to the 6.
2040.
All right, I got 65,536 unicorns. All right, let's see if 6 is different. All right, number 4 and number 6 are the same kind of problem. So maybe if I show you 6, y'all can go back and do 4. All right, so how is number 6 and number 4 different? Look at them. It does not give us the beginning amount of money. What does it give us? The ending amount. It says in bold print on number 6, you have $575 in your account at the end. So where do y'all think it goes in the formula if it gives you the ending amount? Beginning amount goes for A, so ending amount goes for Y. So we're going to have to put 575 on the left side of the equal sign. All right, now everything else you should be able to fill in. We don't know the beginning amount. We'll leave that A. What else do we know? We know 4 years. Where does 4 go? Good, it's your power. And we know our interest rate. So that's going to be 1 plus what?
2.
Now it says 2%. What number do I put in the formula though?
0.02.
Yeah, move the decimal point back twice, 0.02. All right, so that's how you set it up. Anybody got a question on that, how we set it up? Feeling good? All right, so now what I need y'all to do, I need everybody to take your calculator, type that in, give me a number. This one's going to have just an extra step. So I got 1, 2 to the 4. All right, I got a decimal. Let's see if we got the same thing. I got 1.082. All right, so I said this one's got an extra step. What's the last step going to be if I want to solve for A? What do I do with that 1.082? We divide it. So y'all do 575 divided by 1.082. That will give you how much money you started with. 575 divided by 1.082 is, all right, I got $531.42. All right, so I showed you guys how to do number 6. You guys now try number 4. Alright, so 4 says I have 30,000 at the end, so that goes first. Investing 6.5, so that'd be 1 plus 0.065. How much did I start with? 6 years. Alright, so that's how I set it up. 9. I got $20,904.73. Somebody check that for me. Oh, you get that? Okay. All right. All right. So number 1, we did these yesterday. Bring your x over as your exponent. That's going to be 5 to the x equals 625. All right, remember, we got to make them the same base now. So look at the board. 625 is 5 to the 4th. So I got 5 to the x equals 5 to the 4th. This one's going to be really easy. Just mark the 5s out, answer's 4. All right, 2 looks very similar. I'll give y'all a chance to do that. All right, I haven't worked it out, but everybody's saying number 2 is 5. Do I need to show that one?
Yeah.
We're good? All right, let's do number 4. Everybody try number 4, and then we'll go back. If I show you 4, then you should be able to do 3. They're the same kind of problem. All right, so you guys take a second, try number 4. Yep. All right, so we know it's going to be 1/3 to the x power equals 243. All right, so Jason, if I've got to move this up to the top right here, what happens to that number when I move it up? Good, it becomes -1, right? Because right now that's a 3 to the positive 1 exponent. You move it up, it'll be 3 to the -1. 243, I don't know what that is, so I'll look right here. It's 3 to the 5th. So x equals -5. All right, I showed you that one. So y'all should be able to do number 3 now, because it's just like number 4. What'd y'all get on 3? I didn't do it. What'd y'all get? -6. Good, Jason? All right, let's look at number 6. You cannot have a decimal, so we got to punch that in our calculator and make it a fraction. So I got 0.04. I want to make it a fraction. So on this calculator, I'm not even sure how to do that. There we go. 1/25. I got 1/25. So I got 5 to the x equals 1/25. All right, I'm going to change that into 5 squared. And when I move it up, it'll be 5 to the -2. So for that one, I got -2. All right, so here are my answers on 1 through 8.
Whoa.
Check those answers as you work, and then we'll start on the bottom. Did I mess up? And y'all got 9 to the x equals 243. Look, when your x is in this spot right here, guys, you just got to make the base the same on each side. All we have to do from here, Jason, is look at the board. So I got 243 there, and I got 9 there, so I'm going to use 3 to the 2nd and 3 to the 5th. So this side's 3 to the 2nd, this side's 3 to the 5th. Mark them out. My answer's 5/2. All right, we're good on 7.
Yeah, do you get that twice?
Yep, twice in a row, 7 and 8. All right, somebody else had another one we should look at the bottom. Which one was it?
It's a lot easier to think of.
14. All right, we're going to do 3 or 4 problems on the bottom, just for my video, if nothing else. Let's start off on number 9.
Okay.
All right. All right, so Willie, set this up for me as an exponent problem. How you set it up?
2x.
Well, it'd be x squared, because that becomes your exponent. So y'all need to write down x squared equals 81. All right, so I showed y'all these yesterday. We got to get x by itself. Willie, right now, that is 2/1. So if I got to get that to cancel out, I got to multiply it by the reciprocal. So I flip it, I get 1/2 there. All that cancels and gives you x. Y'all got to type that in your calculator now. 81 to the 1/2, that'll give you the answer. Let's check it, Willie. 81 to
How do you type it in the calculator?
1/2 power. I got 9.
There you go.
Answer should be 9 on number 9. All right, let's do the next one. All right, Willie, you got another shot to redeem yourself. Set up number 10 for me.
It's x squared, no, 15x.
15 to the second power equals x.
Yeah.
All right, so why are problems like this the easiest problems on the sheet? Because x is already by itself. All you got to do is just type in 15 squared or look at the board. 15 squared is 225.
Yep. What board?
All right, so somebody had asked for number 14. Let's do 14. And I'll stop if y'all don't have any more questions and let y'all finish and we'll just check. 14, I got log base A. All right, Kellen, is this the one you were asking about a minute ago? All right, you guys try 14 before I show it. See how far you can get with it.
I'm not gonna
Try 14.
I got brain dead. How do you square 5?
All right, Nathan Willis, set up number 14 for me, please.
A to the 1/3.
A to the 1/3 equals 12 to the 1/3. Does everybody understand how that one goes to 12 to the 1/3? There's an understood 1 right there. That's where the 1 comes from, and this number always goes on the bottom.
So A is A equals 12.
That's right. If this exponent is the same as this exponent, you can just mark them out and get 12. All right, so you guys continue to work. I'll be around to help you, and then we'll put some answers